This is StarLogo Nova, made by people at MIT, and it turns out to be a great tool for modeling chemical reactions in which populations are important. So let me show you how to use it. This one here is Sharks and Turtles Modeling Weak Acid Equilibria. I'm Steve Sogo. So as we scroll down here, you'll see this big green square. That's the playing field is what I call it. That's where the reaction will occur within those bounds. First thing I'm going to do here on the left, you can see these blue buttons. One is Setup. Click Setup. And there now are shapes, figures that represent molecules in this playing field. But they're too small to see. So up here is an important button. You see it says Edit Camera. Click that, and now I can zoom in on the playing space. I can also tilt using the right mouse. Okay, so Edit Camera is a useful tool for you to know about. If you like the view, you can lock the camera. So now you can see there are these green turtles. Here's a blue shark. Here's a yellow sphere. These represent molecules. Specifically, the green sea turtle represents a weak acid, the shark represents a conjugate base, and the yellow sphere represents a proton. So if you know something about chemistry, you would understand these can form an equilibrium. That's what I'm going to model here. There's a graph that keeps track of the weak acid population. That's the population of green sea turtles. To make things happen, I click on this button here on the left, blue button called Mingle. And now you see they start to move and reactions start to occur. So let me stop by clicking Mingle again. You can see the graph shows a declining population of weak acids, a declining population of the turtles. And we'll need to watch closely to figure out how does that happen? Where do they go? To understand the turtle population drop, I've made a simplified model here that has only a few turtles. So as we watch them go, you'll see that each spontaneously dissociates into a proton and a shark. And this is a random event that occurs with some probability. And that's why the turtle population drops over time. So, some other controls that may be useful to you. Up here, engine speed allows you to make things go faster. Everything's happening faster, or slow it down. And then you get the slow motion camera that may help you see things more clearly. There's another important control. Up here, and it's called View Code. So let me click on that and show you what it does. So now, what that enables you to do is to see how does this world work. So it's block coding. You can drag these out. You can put them back in. And there are choices over here on the left for commands that you can put into your coding. But what's important for you to know here is what happens in the beginning. When setup is pushed, it creates 60 turtles, 2 protons, 2 conjugate bases. Their shapes are defined. The turtles are the weak acids. The protons are the spheres. And the behavior of those are defined by code. The turtles, for example, when Mingle is toggled, they move, and they have a 1% chance of dissociating. This is the dissociation event, which creates 1 proton, creates 1 conjugate base. So these can be changed to alter the simulation. The conjugate base has its own coding. That's the sharks. What happens on collision with protons? All right, if you change the code, which I just did, You can see up here there's this green button that says Run Code. You need to click that, otherwise your changes do not take effect. And then you can go back and run your simulation and see how did your changes affect the outcome in the equilibrium.